Testing. Hello, everyone. Welcome to the final talk of the main stage. I'll keep it short and sweet. My name is Hamza. Thank you for the intro, Melissa, founder of GitStart. With GitStart, we're an AI company. We have shipped over 1 billion lines of code for some of the largest code bases like Chrome, Firefox, and many unicorns. And today, I'll tell you the best practices to make your code base AI ready. So before we start, let me tell you when my advice will be horrible for you to take. Number one, if you have a small code base. If your code base fits within 10 million tokens, and you can check that online, don't follow anything I tell you today. Second reason not to follow my talk today is that if defect rate really matters for your project. If you have a project where you're having a hard time keeping bugs down, LLMs or even more code shipping to production will not help you. Or if you have a bus factor problem, which, if you don't know, means that if a developer takes a holiday or a leave, you have a lot of lines that are affected. If you add LLMs to your project, your developers will have less context over time, and that's a risk you need to take. The third reason you should not do this is that if throughput is just not your bottleneck, like many companies I see every day, day and night, some of them, their bottleneck is on engineering. It's product, it's design, it's rollouts. If number of lines of code is something that is not bottlenecking your company, you should not follow my talk. And finally, if you want to build prototypes, get the LLM to build the whole thing. You don't need to follow my talk. This is about large, maintainable code bases. So let's start with good code bases, which are designed for humans. They're a bit similar to databases, where you're sort of storing code in a repo, you're getting it back. In some ways, it's designed for humans to edit, and it's for machines to run. And there's a lot of trade-offs that come with code bases, just like databases. You have the runtime constraint, where you need to make sure code is performing well. You have the DevX constraint, where you want to make sure that your developers have a good feedback loop. And finally, you have collaboration, where you want to make sure that as your team goes bigger and bigger, you can all work on the same code base, and you break it down into smaller bits and so on. Now, the one constraint that we all have these days is LLMs. Like, how does that change our constraints? How does that change how we design our code bases? And that's going to be the focus of the talk today. So the first tip I want to give to all is that LLMs are like humans that have a lot of knowledge in their head, and they really like stories and product. They're good at code, but they're also good at product. So one tip that I'll give to everyone is that if you can somehow bleed your product knowledge into your code, they will be a lot more effective. And the reason behind this slide is because whenever we are writing code as developers, we have code, but a lot of time we have Zoom meetings, we have Slack conversations. We're learning our product on the way. That does not live in code. But LLMs are not in those conversations. So the more you can bleed your product into your code base for them to learn, the better they'll perform at managing that code base. So simple tip. If you go back to your code bases, the one thing you can do to your code bases today is to use the same names across your product into your tech stack, into your code. Don't have a different table name for users when your sales team is calling them something else entirely. Second tip is to make sure that your product docs interleave into your tech docs. A lot of the new LLMs are really good at going to web pages, scraping them. If you can link your product docs from your tech docs and back, these scrapers will be able to get full context end-to-end of not just what the code does, but why does it do the way it does. So be very liberal with your comments. If you have a support ticket, put them next to the function that updated that support ticket. And finally, you want to be very consistent across product and engineering, and that sometimes matters more than correctness. As engineers, we love to correct things. So sometimes sales team will tell us something. We're like, no, that's wrong. We need to change it. Try not to change it. Try to keep the same names across the entire stack, because that will be consistent for LLMs to pick up. The second thing I'll keep is build around domains. Now, you can also do microservices and do all sorts of jazz. But my recommendation to most companies before LLMs was that you don't have to move to domains on day one. They add some complexity. Start simple with a monolith. Add domains over time. In my experience, though, you want to add domains a lot earlier. The biggest reason why is basically context length. If you can somehow partition your code base into small domains, LLMs can just pick up the domains that matter to them and really do a really good job. So build self-contained subsystems around domains that LLMs can work on. And the second advice is a bit counterintuitive, or not the best, where you want to keep all the context of a domain in the same place. So try to use frameworks or languages that enable you to co-locate your DB schemas, your service contracts, your APIs in a way where if I'm in that domain, I have everything I need to work in that domain. It's like a mini code base of company altogether. And finally, as you're doing these domains, just like the first slide, work with your product team. Go to the business team. Figure out what is the domain for the company, not just necessarily for your particular code base. And then you can slice them down. You can either slice them as folders, as repos, and you can build agents around them. Like you can have a billing agent that understands your billing domain really, really well. You can have your auth agents, campaigns, and so on. Microsoft launched a lot of tools lately where GitHub Copilot enables you to build these domains around pieces of code for the enterprise product, and that can be super helpful as you guys are integrating LLMs. My third advice is also a bit counterintuitive, where if you guys know about the whole Google pyramid of testing, you want to be able to write a lot of unit tests and some end-to-end tests because they're expensive to maintain. Now, with LLMs, number one, the cost to build and maintain end-to-end tests is gone down drastically. So number one, the whole calculus is different. But the main reason you want to add end-to-end and test is because it provides another feedback loop for LLMs to work on. I was working with a CTO of a large consumer app in the US. They have hundreds of millions of users. And one of the first things he mentioned was that when they rolled out LLMs, they somehow are really good at passing unit tests, but they create new bugs that are impossible to catch in the normal testing framework. And the only way they could get and catch those bugs is to make these very high-level, broad tests that can catch those edge cases. So if you write a lot of unit tests, they won't be helpful to catch bugs caused by LLMs. But if you write a lot of integration and end-to-end tests, they have a much better shot at finding these counterintuitive bugs that your unit testing framework may not be able to find. So finally, focus on broader tests more than laser-focused tests, because LLMs will find a way to hack them one way or the other. And finally, and this is also a bit interesting, I remember back in my Microsoft days, I was working with the creator of this book, Design Patterns, and he told me back in 2010 that the book was great for design patterns, but no kid wants to study today. Nobody wants to build a factory pattern and all the jazz. Everybody wants to write JavaScript and TypeScript. And that was good for the time we have. But it turns out these LLMs have read all these books. They've read all the materials. For the first time, you guys writing verbose code that follows design patterns actually improves LLM performance. And this is actually a recent thing, because if you go back to the LLMs in the first iteration, they were not very good at writing Java code or not very good at writing type code. But once you add chain of thought, the new O1 models, they work so much better when you have a fully typed verbose code base. So Java code bases are going to work a lot better with O1s than it did with 4.0 and so on. And the main reason why is very simple. The more you can be explicit, the more you can be standardized, the better LLMs will perform. The more you guys are implicit, the more there's magic, LLMs will not go well. So if you go back to your Ruby code bases and you have some monkey patching happening in a folder, take it out, because LLMs will have a very hard time understanding and figuring it out. Finally, as a summary, build end-to-end subsystems around these domains. Align your code with technical and product docs. You want to combine your docs as much as possible, so LLMs have a very good context end-to-end of the entire product they're trying to build. Wrap up your end-to-end tests. And finally, perhaps try explicit type languages, or even if not, use the types you already have in Elixir. There's a new project happening with Ruby. There's types and so on. Just add them. LLM will just work a lot better. Now, we're Get Started. We've shipped 1 billion lines of code for some of the largest code bases. We've seen all these patterns in action. So if you want to know more how we do it or how to see these patterns in real life, come check out our booth next to the Asian food store. And that's it. Thank you.